In this video, we are going to write 50 SQL queries so that you can learn, understand, and master SQL. We are going to look at how to do select operations, how to write where clauses, how to use and or not, and how to combine all of these things, how to build joins in SQL, how to do group bys, order bys, and so much more. The video has got lots of practical information and real world tips. And I have got a full-length example dataset as well as all the queries for you to download. So feel free to check the video description for that. As this video is quite detailed, I highly recommend that you set aside time and watch it in one sitting for best results. Let's go. We will be using the MySQL workbench to build our SQL queries. I have already preloaded our Awesome Chocolates database to this, but you will need to load this using the instructions that are available in the video description. Once you have the Awesome Chocolates, then we can go and create some SQL queries. To make a new query, here is my plus SQL button in the corner, and when I click on it, I will get my query editor here. And whatever query we write, we can see the output results right here on this workbench. The first step before even we write any queries is to make sure that SQL or MySQL is using the Awesome Chocolates database, because there are multiple databases here. Right now, World is the database that is set up. So I'm just going to double click on Awesome Chocolates, and that will basically activate that database. As explained earlier, we have got several tables here. We've got a geography, people, products, and the sales tables. Let's go and take a look at the sales table itself and see what is there. If you are not familiar with the database and you don't know what tables are available themselves, you can use this simple query called show tables. And when you run this, it will list all the tables within the database. And to understand what is available within a specific table, you can also use the describe and then table name, and you can run that query, and then that will show you what is in the sales table. So describe sales tells me that the sales table has these columns and this is their data type and some extra information about that. Normally, when you are writing SQL queries, it is expected that you're familiar with the underlying tables and the relationships. If you don't have that knowledge, writing SQL becomes really hard. So for our first example, we are just going to look at the sales table and then see what is there. This is where the select statement comes in. So we say select, and then if you simply say star, that means you want everything, all the columns from, and then the table name. Sales. So select star from sales, and then to run this particular statement, you can use the run command here, or you can also press Control Enter in the MySQL workbench, and then that will basically run that. The exact way to run these commands and the shortcuts differ from one system to another. For example, MySQL workbench is using Control Enter to run the current statement, whereas previously in my other projects, I would use SQL Server Management Studio, SSMS, and that has its own shortcut. So depending on which database you're talking to and which SQL Management Studio or Workbench or some other thing in Oracle that you're using, you will need to press a different shortcut. Whatever may be the process, once you run the query, if there are no errors, you will see the output result here in a nice grid format. And here you can see that it is basically listing all the rows within the sales table one after another in this fashion. Now let's just say we don't want to see all of these. We only want to see some columns. For example, I just want to see sales date, amount, and customer columns, these three columns. So I can write a different SQL statement, select sale date, amount, customers from sales. Now, because we have not typed the table name, there is no auto suggest available here. But once you type the table name, you will, if you go back here and then press comma and then start typing some other column, for example, boxes, you will see that it will show up these auto suggest options. So it's a good practice to first say select and then from table name and then come back and write the columns. That way you don't need to remember or make sure that you're not making any spelling mistakes. Let's run this one. And now I'll get a kind of truncated version of the table, just those few columns. Remember, this is still listing all the data. Right now, within the management, that workbench that we are using, our queries, whenever they run, there is a limit of 1000 rows. So even though my sales table has around 7000 rows of data, for the purpose of viewing, it will only just show 1000 rows. So if you want, you can kind of say don't limit or set a higher limit. Normally, when you are building the queries here, your intention is to make sure that everything is working correctly. And then you would probably use that query somewhere else, like maybe in Power BI or in some other system. So you don't need to worry about seeing all the data. But another use case is you will run the query and then you will export the data, in which case you may have to set a limit higher value here or no limits there. So that's our first few queries. We just looked at everything in the sales table, and now we looked at a bunch of columns. You don't have to specify the columns in this exact order. You can also say select, and then for example, say amount, customers, and then geo ID from sales. These columns are out of order from the original data, and then when you press Control Enter, you will get those rearranged for you. For our next query, we are gonna add a extra calculation, that is amount per box. Select, and then I want to see my date. So our date is sale date. And this can get a bit tricky, so I'm just going to write from sales first and then come back here, and then from here we can just go ahead and build those extra things. So sale date, and then I want to see amount, I want to see boxes, and then we want to add a calculation which is amount per boxes. So this is where we just take amount divided with boxes, and that's basically amount per boxes, because here I'm doing an arithmetic operation. And then let's see the result of this. So here we get sale date, amount, boxes, and amount per boxes nicely calculated to you as an extra column. You can do lots of different operations, arithmetic, text, and multiple different complex things. During the course of this video, I will show you a few other variations of how we can use this. While this is all good, the amount/boxes here is not a very pleasant way of looking at that name. So maybe we want to call this as amount per boxes here on the display. But the operation itself is amount/boxes. So how to add a name? That's our second job. I'm just going to copy this query, paste it here. And then once you define the calculation, you can give space, and then you can either use the word as, or you don't have to use the word as also. And then within single quote, you can give a name that you want. So I'm going to say amount per box as my name. So your calculation space amount per box. And then when you run this, you will get a different column name. So many times you may want to give it a proper column name. As I said, you can write it like this, or you can also say as and then write it. Basically, as means you're creating a synonym there, and both of them are going to give you the same result. So far, all the queries that we have written are returning all of the sales data. Now let's understand how we can use the select statement to impose an extra condition onto the query. That means I just want to look at all the sale amounts more than $10,000. So this is where the where clause comes into picture. We can simply say select star from sales, and then in the next line you'll say where, and here you can specify any number of conditions and combine them creatively. We'll write one simple condition for now. Later on I will show you more complex conditions. So where, and then you will say what the condition should be. This condition can be column greater than or column less than. So here my column is amount greater than 10,000. And when you run this, you will see all the amounts that are more than 10,000. So here you can clearly see that none of these amounts are under 10,000. Everything is more than 10,000. If you contrast this with maybe this query, here you can see that we got an amount of 8414, 532, 5376, etc. But none of those amounts would show up when I run this particular query. This is only giving me those sales. So one way to think about this is this operation is like filtering in Excel. Essentially, when you set up a filter, the filter criteria that we give is either greater than, less than, or some other operation. So whatever it is, that's where the where clause comes in. Using where clauses in SQL is one of the most important aspects when it comes to data analysis. That's why we are going to spend next few minutes understanding different types of where operations and learn it at a deeper level. Let's go. Before we get into more where clause details, first let's understand how in this query we are seeing all the results, but I just want to see this in the order of amount. So that means lowest amount on the top, highest amount at the bottom, or vice versa. So this is where the next clause of the query comes in, the order clause. So I'm just going to copy this here and where amount greater than 10,000, and then you can say order by and then specify the column. So for example, order by amount means this is gonna give you a result of all the amounts greater than 10,000 and then arrange them by the amount order in the ascending order by default. So control enter on this and you'll see that lowest 10,000 greater than amount is $10,010, and then this keeps going like that up until 15,148. I believe at this point we reached the limit of 1,000 rows. Probably there is more. But another way is if I, for example, change the order by amount and then say DESC, then that means I want the order in the descending order. So you can see that, we do have some 25,000 amounts, but because they are more than the limit, they are not showing up on the screen, but our highest amount is 27,000. So this is how you can order the results also. When you are specifying the order, you can kind of go and have multiple types of criteria here. Because the amount tends to be fairly unique, there is no need for us to give the second criteria. But I'll show you another example. So select star from sales where, and then we are going to limit all the values from G1, GOID G1. So where GOID is equal to G1. And order by, and then within the GOID, I want to order this by our PID. So PID and then amount DESC. So we are now specifying two criteria, product ID, and then within the product ID, amount should be by descending order. Let's try this query. So here, we are only going to get all the G1 items. None of these values will be for anything else. And within G1, you have got P01 and then their information going like this. And we will then have P02. Again, it kind of kickstarts from 16,000, goes down. And then you will have P03, P04 like that. So this is how you can use where clause as well as the order by to impose multiple sort criteria. So where clause is like filtering the data in Excel and order by is like sorting the data in Excel. As I mentioned earlier, where clause is one of the most important things in SQL. So I'm going to show you a few more examples of that. Our first example is going to be, we want to see all the results, all the sales where the value is more than 10,000 and the year should be 2022. We do have the sale date information here, so we can just do a year-wise operation. So we'll try our first query here. Select star from sales where amount greater than 10,000. And now we need to have the second condition. So amount should be greater than 10,000 and date should be within 2022. So this is where the AND keyword comes in. You can use AND or not, etc. to kind of combine conditions and add multiple criteria. So amount greater than 10,000 and sale date. And then here we can specify a date. So for example, you can simply say greater than anything in 2022. Given this data set, the data has only values for 2021 and 2022. We don't have any 2023 values here. So one cheating way of doing this is sale date greater than, and then you can simply say greater than or equal to, and then you can specify the date. Within MySQL, the date format is YY, MMDD. So year, month, and day. So I can say 2022 01 01 like that. So we are basically building two conditions where amount is more than 10,000, date is this, and then I'm just gonna run this. So we will get all the values within 2022 that are more than 10,000, and those information are coming up here. You can see that our sale date kind of goes all over the place, but it always stays within 2022. Like I mentioned here, we are simply saying greater than 2022 0101. So what if we have 2023 data or 2024 data? In that case, this one is gonna bring all of that data as well. So another way is we can kind of check what year the sale date is and then look for whether that year is equal to 2022. So we'll write an alternative query here. So select, and this time I don't want everything. I'll just say sale date amount from sales where amount is greater than 10,000, and instead of directly accessing the sale date, we can do an operation on it like year of sale date. So year is a built-in function within SQL, and using that I can basically extract the year portion of the sale date, similar to how the year function works in Excel really. So year of sale date is equal to 2022. As year will return a number, you can just do it like this. You don't need to put any single quote or anything like that. And then we will order these by order by amount DESC. So let's just see how that one will look. Control enter on that. So we'll get all the 2022 amounts in the descending order going down like this. Next up, let's try to find out all the sales where the number of boxes is between 0 to 50. Let's go. This is where we are gonna look at the between condition. So again, we can simply say select star from sales where boxes, and when you're writing a condition where the number is between 0 and 50, you can do it in a couple of ways. One way is you can say boxes is greater than 0 and boxes is less than or equal to 50. So anything from 0 to 50 boxes, this is what I want to see. And when you run this, you will get all the values, and we are looking at the boxes column. Here, if I click on that, it is sorting, but essentially you will see that, this is how those shipments are going from 1 to 50. As I mentioned, this is one way of doing. SQL also offers a between keyword. So we're going to try the same with the between. So select star from sales where boxes between, and then you specify both numbers with the end in the middle. So it'll say 0 and 50. And when you do it like this, control enter, you will get same result really, but this time the boxes are there. Of course, the between function is inclusive, so 0 is also shown here. So 0, there are a couple of shipments where we had 0 boxes go out. Not sure exactly what was happening here, probably canceled shipments, but the 0 is also shown, whereas with this result, it's not showing because the condition is greater than. So here, two different ways to write the between condition. Whichever way you feel comfortable, go with that. Hey, I just want to remind you that while learning SQL is a good idea, if you don't practice, then you will forget most of the concepts. That's why I have prepared many practice homework problems for you that are showing up on the screen. Feel free to refer to the video description and download these practice problems as well and try to solve them. Some of them are easy, some of them are hard. The hard ones require you to investigate a little bit more beyond what is covered in this video, but I highly encourage you to practice these so that you can learn and understand SQL better. Good luck. Our next where clause example is going to be, I want to see all the sales or all the shipments that are happening on the Fridays. So again, we have got the date here. We now need to use the another function within SQL to see that. So here I'm going to say select from sales, and then here the columns that we want are sale date, amount, and then boxes. And I also want to see what weekday it is so that we can then kind of check this. So we can use the weekday function and weekday of sale date. MySQL Workbench offers like kind of a built-in help in screen, but it doesn't really show help for everything. So here, even though I use it weekday, I mean, it does show some information, but not a lot. So here I can see that weekday returns 0 for Monday, 1 for Tuesday, and then 6 for Sunday. So essentially, if I filter correctly, we should expect to see just 4 there because 0 is Monday, so 4 would be my Friday. So sale date, amount, boxes, weekday sale date as within single quotes, day of week, and where, and then here I can just kind of give my condition. We have already set up a column, so we can directly refer to that. I'm going to try this. I haven't tried this previously. So day of week, because there is a space there, we need to refer to that column with the back quote here is equal to 4. Let's try this. Ooh, I did get an error here. So this is our first SQL error. Let's read this. Unknown column day of week in where clause. All right, that kind of makes sense. I guess we can't reuse this there. So we are gonna try the usual route, which is weekday sale date is equal to 4. So that works as expected because we kind of did the same thing earlier with year of sale date equal to 2022. So this one is working. I thought we could reuse that. And these are all our shipments that happened on the Fridays in our data. So we do a lot of shipments on Fridays, and that those dates are showing up, amount and boxes, and the day of week column comes up here. So far, we have only been using the sales table, but our database already has some other tables as well. So I'm going to use some of these other tables to demonstrate a few more tricks and concepts of SQL that are very relevant when it comes to data analysis work. So here, I'm going to use my people table. We haven't used people table so far. So our first step is to just kind of explore what is in the people table. So we'll say select star from people, and that will give you all the people listing here. It's a very simple table that tells me the names of the people, their ID number, which is then used to map to my sales table, their team, and the location in which they are operating from. So our next criteria here is I want to just see all the names, all the people that are in either Delish or Juice's team. So here again, you can do this in a couple of ways. We can say select star from people where team equal to, and then single quotes because this is text, Delish, or team equal to Juices. So here we are using the or condition instead of and condition because person cannot be in both teams. They'll be in one of these two. So if they are in this or that, we want that. And then when you run this, you will see all the Delish and probably misspelled there. I'm gonna just see. Oh, it's not Juices, it is Juicies. So that's why the second result is not coming up, Juicies. So I'm gonna adjust this Juicies. And yeah, we're gonna get both Delish and Juicy's team members here in the listing, nice and good. So this is one way, but if you have got, let's say you want to get all the teams where the team names could be A, B, C, D, like that 5, 7 values, then typing this or condition is a pain. So this is where SQL also offers a different way of doing this. It is the in clause. So select from star from people where team in, and then open the bracket and then type the values that you want to type. Because these are text values, everything needs to be in single quotes. And when you run this, you'll get the same result, but now we are using the in clause to provide all the possible results. So in offers a more flexible way in which you can add multiple conditions and kind of get all the results that you want. Another common thing that we do in SQL is pattern matching. And this is where we can use the like operator in SQL. So for example, I'm going to select all the people So select star from people where salesperson like, and then I want to just see all the names that begin with B. So we'll try a few different things. Intuition tells me if I simply say like B, I'll get all the names that are having B, and we get nothing here. This is because it's also expecting some sort of a pattern. So if I click here on the like, you will see the help is showing me this, and then there is some extra pattern syntax there. But I believe if I say B percentage, then I'll get all the names that are there. So like is the word, and then whatever pattern you're giving, you can give the fixed items, and then percentage means anything. So it basically looks for anything that begins with B. Let's try this again. This time I want to have a list of all the people where B is anywhere in their name. So this is where percentage B percentage comes in. That means it can have anything B and then anything after. And when you try this, you're gonna get a little bit more people because all of these people have B as well. Chess Bonnell has a B in the middle. Mary O'Brien has a B in the middle. Marnie, and all of these other people. So that's the like operator. I really enjoy working with the like operator, and that reminds me, if you are enjoying watching this video, don't forget to give it a big like. All right, enough with the like puns. Let's go on and learn some more SQL. Apart from like and in and where, etc., SQL also offers many other operations that you can do on the data. I'm gonna just scratch the surface here by introducing one another operator, which is the case operator. For the purpose of this, we'll need to go back to our sales table. So select star from sales just to kind of bring us back to the data. And then you can see we forgot the from here. So select star from sales, and then it gives you this data. And instead of seeing all the sales and the amount values, I want to add an amount category as a column where any amount up to $1,000 will have an extra label here that says under $1,000, and between 1,000 to 5,000 it will have a label that says under 5,000, and anything between 5 to 10K it will have under 10,000, and anything more than 10,000 it will be having another label. So basically 4 labels that we want to have a categorization of amounts. If you ask me how to add that kind of a thing. So here we can use the case operator within SQL. So I'm gonna first write the query and then I'll explain it to you. So we say select, and then let's just print date amount. So sale date amount, and then the next one is an operation. So it's a good idea to kind of break your query into multiple lines. That way you kind of know exactly where everything is. Normally within like when you are building bigger queries, usually you just have select in one line and then fields, and sometimes if there is fields going on, then they'll go into multiple lines like this. And this is where you can use the tab key to indent your query so that everything looks nice and pretty. So select amount, sale date and amount, and then the final one is case, and then you can say when, and then build your condition. So when amount is under 1,000, then what is the word that you want to have? You want to say under 1K, and then you can keep building these when conditions. So I'm gonna just indent this correctly. So when amount is under 5,000, then under 5K. When amount under 10,000, then under 10K. And then finally you can have an else operation. So it'll be else and then whatever you want. So here I'm gonna simply say 10K or more, and then end. So this is the basic construct here. So you start with case and then end. And then once this field is constructed, you can give it a name. So we will call this as and as amount category. So basically we have took the sales amount and then kind of built this categorization. I'm just gonna collapse this for a minute. And from sales, let's just run this. You can select all of this or you can place the cursor anywhere and then Control Enter. This is gonna give you those amounts and then amount categories. So you can see that it has nicely categorized all our amounts. This is very helpful, especially when you're trying to build some categorization based on your data, either using numeric values like I have shown or text values, so that you could then either display it on the screen or use it to build a where condition or map it out to another table. This brings us to the end of our part 1 of the SQL journey. So far we have been building queries where all the data sits in one table and then we are doing operations on that data. In the subsequent part of this video, we are going to look at joins so that you can take data that is in multiple tables and then combine that to create one output. Let's go. In the joins part of this video, I'm going to show you some practical examples and briefly explain what is what. But if you want to learn a little bit more about how joins work and how to use them for many practical scenarios, you will need to do a little bit of further study. I'll talk about some resources for learning SQL later on at the end of the video, but for now let's go and build some joins. Before I do that, I just want to save my SQL file because then I can come back and refer to these queries, or I can share these examples with you. So to save this, I can simply go to File and then Save Script, and this will just open up my computer. We'll call this as queries1, and then it's a .sql file. It gets saved here. We'll open a new tab and we'll build our next set of join queries here. So these are our base queries, and then we'll now do some join queries. In order to join the tables, you need to understand how the tables are linked up to each other. We've got a very, very simple database here with just 4 tables. We've got a sales table, and the sales table itself has these columns: SPID, GOID, PID, etc. And each ID column links up to the other tables. So for example, PID here refers to PID in the products table. Likewise, SPID here refers to SPID in the people table, and GOID here refers to the GOID in my geography table. So it's a very simple database, and things are kind of mean the same thing in 2 different tables. So using this information, our very first query is going to be, I just want to look at all the sales data and then see the person name also. So for example, if I simply say select star from sales, we are seeing all the sales data. We do have the SPID here, SP01, SP02, SP12 here, but we don't know exactly who that person is. So I want to see their name as well, which is not available in this table. If I want to see who the SP01 is, I would need to go to the people table. So select star from people, and then we can see that SP01 is Barfoni, SP02 is Dennison. So really, those are the names that I want to see against the actual data. So this is where we are going to join sales table with the people table. So our first join is going to be select, and then this is where really having the from clause ready before writing the select helps. So I'm going to say from sales. And when you join the tables, it's also a good idea to give your tables small names, because your original name could be a little bit long. So instead of saying sales, I'll call this as S. So you can directly space and type S, or you can say as S. This is kind of like a shortcut. You just don't have to type the way. So select from sales S, and then we will say S dot, and then start typing the values that you want. So I want to see sale date, S dot amount. So for now, we'll just do this. Select S dot sale date, S dot amount from sales S. If I just run this query alone at this time, you'll get sale date and amount. This is not enough. We also need to know exactly who that person is, what is their name. So then we want to join this. So this is where the word join comes in. Join, and then you will specify the other table. Join people, P on, and then on will be where the condition will be specified. So it needs to join in such a way that the sales table SPID is same as people table SPID. So when the IDs match, then the names can be extracted. In a way, this is like doing a complex VLOOKUP behind the scenes in Excel, but SQL uses more optimum and better way of handling all of these things. So on, and then you will kind of specify the mapping columns. P dot SPID is equal to S dot SPID. So that's the criteria there. That's and then once you have joined, you can also use the columns from this table here. So I'm going to get P dot, I think it's called sales person. Yeah. So S dot sales date, S dot amount, and P dot salesperson. For fun, I'm going to print S dot SPID as well, so we can kind of see what that is. And if you want, you can also print P dot SPID. This will be same anyway, because we are kind of saying that's how they should be matched. And when you run this, you will get Barfoni, SP01, SP01, Dennison Crosswhite, SP01, SP02. So basically same ID is matched, and then we'll get their corresponding name here. So this is basically how you do the joins. You take data from two different tables and then you combine them on one or multiple key columns. So these are called key columns. Basically, that means it will be same and the intent and the purpose and meaning are same across both tables, and then you can map them out like this. As I said, there is more to this. I'm trying to oversimplify the matters here, but this is the join operation. When you are joining things, you could join them based on multiple ways. The easiest is join. Here you're not really specifying anything. SQL will do most of it. But if you want something more specific, you can tell the type of join that you want. So the most common type of join that you see in business situation is a left join. What it simply means is you've got two tables here. You have got the sales table and the person table. I'm just gonna do a little bit of drawing here. So imagine this is our sales table. And then this is our person table. So the way I have written our query is we started by writing from sales first. So this is my left table and then this is my right table. When I say a left join, what it means is my SQL will try to keep all the data in the sales table because that's the left table. And then if there is a matching value in the person table, it will bring it over. So that's what a left join is. In many situations, you will simply use a join because the data will be same across both tables. If I have got an SPID here, for example, if I have got SP01 here, I will have a matching record in the persons table. But occasionally we may not have a matching record there. So in that case, if I use a join, then what happens is because there is no matching record there, that data may get excluded. So that's where you use the left join to ensure that the data on the left side of the query, which is the sales table here, is preserved. So just as you have left join, you also have right join, and then there is more complicated wordings of these and variations of this. But for better results, I recommend that you read a book or an article. I will link to some of them in the video description so that you know this all makes sense. If you have done some work within Excel, especially in Power Query, you would notice that Power Query also has the same wording there. It has the left join and right join when you merge the queries. Let's go back. Let's try one more type of join before we get into more complicated joins, which is just as we are seeing the people person names, I want to see the product name that we are selling in these shipments. So we'll try a different one. This time we'll join with the product table. So select from sales S and then S dot sale date, S dot amount, S dot PID. It's showing me this red underlining. This is because the previous query is not terminated. So that's where the semicolon comes in. When you finish a query, if you put semicolon there, then SQL knows that that's where that statement finishes and the new one can begin. Even though it shows the error when you select and run that portion, this will run perfectly, but it's a good practice to kind of delimit the queries with that semicolon if you are building multiple queries in the same file. So select sale date, amount, and SPID from sales, and then we will this time we'll use the left join. There won't be any difference because the data is all there. Products and then PR. For consistency's sake, whenever we refer to products, we'll say PR, and people will say P. That way both tables are with P, so it's easy for you to distinguish. On pr.pid is equal to s.pid. And then now that these are linked up, we probably don't need that. We are going to just say pr.product there. And then let's just run this. We'll get our product names here nicely printed for the amount. So we know that on this day, we made $259 for Baker's Choco Chips. And then this continues like that. So this is my people join, and then this is my products table join. We are using left join. So if there is a product name within the sales table and a product ID in the sales table that doesn't have a matching product ID in the product table, it will still come up here, and then where the name would be, it will simply be blank or null because there is no matching value there. Right now that is not the case. It will show for everything. Just as you are joining two tables, you can join multiple tables also. So that's what we are going to do next. Just as we are showing product name here, I want to also see both product name and person name in one view. So this is where we can kind of combine both of these queries. I'll be a little bit lazy. I'm just going to copy my query from the top, paste it here, and then copy this clause, paste this here. So we are doing two joins. It doesn't matter, left join, join. So I'm just going to use join here and then do both of these. So we're joining people table, products table. So now I have access to both. So I'm saying p.salesperson. We don't need these IDs. And then we'll say pr.product. And then if I want p.team, my auto suggest is a bit slow. Okay, so this is that query. We'll run this and then you'll see the result, and then it kind of makes sense. So it shows me the sales data where the amount, salesperson, product, and team are listed. Some people do not belong to any team, so that's why there's blank, but otherwise it's all coming up nicely. Just as you're making the joins, you can also add some conditions on top of a join. So when you are building this, the join itself is like one kind of condition because the IDs should match across the tables, but you can also introduce some extra criteria if you want. So for example, we are gonna do the same thing, but this time we will add a condition. The condition would be where, and then we can kind of build any condition. So for example, s.amount greater under 500. And then control enter. You will see all the situations where we had under 500 amount, and then who the salesperson is, what product it is, and which team it is here in the result grid. Just as you're building the condition for the s.amount, which is the main table here, so from clause, you can also build a condition for other things. So I want to see where we had under 500 for a specific team. So I can say and then p.team is equal to, and then we can give a team. So for example, Delish. And then I'll get all the records where our amount is under 500 within the Delish team, and then we get to see their names and the products as well. Remember, some people do not belong to a team, so maybe I will try to extract just those people. So I'll try another query. I'm going to copy this. The reason why I'm copying these queries is because I want to give you a copy of these queries for downloading. Normally, when you are building SQL or when you are learning SQL, you don't need to make so many copies of the queries. You can just continue to build and edit the ones that you already have. So instead of p.team is Delish, I want to see the empty ones. One way to do this is you can simply say is null. We'll try this. I don't know whether they are coded as null or they're coded some other way. So I'm going to try this. Unfortunately, that's not how they are coded in the data. If you remember from here, this one. So here we are not seeing the word null there. They are kind of empty. So that's why even though they are empty, they're not really null. They are considered to be blank spaces really. If they are null, you will actually see the word null printed in the cell. So this is one of the nuances of databases. A database has, if there is really no value, then it is called null. But even a blank value, that's a different perception from a database. So this is not working. So it's essentially, we'll have to do like this. And then that'll give you all the teams where the team itself is blank, but these are the people that had under 500 sale amounts. Let's build one more join. This will be our last join example, which is I want this exact data, but the geography should be either New Zealand or India. So we'll copy this again. Notice that we do not have a join on the geography yet. So for now, we can't even put that filter. So I'm going to add that as another join. Join geo g on g.geoid is equal to s.geoid. You see that I'm not waiting for the auto suggest to come up and I'm typing these values myself. This is where knowing your data is really helpful. If you know your data well enough, then you can build better SQL queries. So one of the key suggestions that I have for you is anytime you are trying to learn or use SQL, first spend some time understanding the data model itself. What tables are there, what columns are there, how they are linked up, or what goes where. Then you can build better SQL queries. So join GeoG on GeoID is equal to sGeoID. And then now I can build my third condition, which is end g.geo in New Zealand, India. So these are all the situations where we had under 500 amount. These are the people, that's the product, that's the team. Obviously team itself is blank because we kind of make sure that that's the scenario where the amount is actually, the shipment actually went to New Zealand or India. We don't have any indication of that information there, like there is no geo column. So it's not necessary to show the column on the screen to access it in your where clauses or whatever. And needless to say, once you finish this job, you can also order this information, order by, and then you can put, for example, sale date so that you can see these shipments in the chronological order. So we had couple of them in the January of 2021, then we have a couple in February, 3 more in April, 2 more in May, like that. We didn't have anything in March. So that's a really interesting way to explore the data and see a precise portion of the data that meets the criteria that you want by building the joins and where clauses. And that brings us to the very last part of our video on SQL learning itself, which is how to use group bys to create report style data sets. My wife, Jo, she does a lot more SQL work than I do nowadays, but we both have fairly solid understanding of SQL. So I asked her the other day, hey, I'm building this SQL for data and Excel people. What topic should I include? And the first thing that she said is, after you cover the basics,
you should talk about group bys and aggregation.
So we're going to do our group bys here. What group by does is it lets you create kind of like a pivot report style things using SQL query. Many times all the data that you want is in the database, but it is at a too detailed level. And I just want to see the data at a higher level. That's where the group bys are helpful. So we'll try the simple ones first. So select, and then let's just group the data by the GeoID in the sales table itself. So we can say GeoID. This is also helpful when we write the from clause first, from sales, and then GeoID, and then I want to see sum of amount. So that's the sum is the function on the amount column by GeoID, and then group by GeoID. Okay, so this is how when you run it will kind of make sense. Basically this is going to create a simple G1, G2, G3, G4, G5, G6 report telling you what was the total amount for each geography. Because we are grouping by GeoID, I can do any operation and then that operation will be happening within that geography. So essentially, this is like a pivot table. Imagine you create a pivot in Excel where you put GeoID into row label area and amount into the values area, and it adds up the values. So that's what the sum is doing. If I want, for example, I can also do average of amount. That didn't turn into green, so probably it is AVG. Yeah. And then I can see what was the average by each geography. I could do a sum of boxes, and then that'll create that. So this is a powerful way to create reports for your situations. Here we are using one table, but if you combine this idea with your joins, then you can kind of take data from 2-3 different tables, merge everything together to create one complex report. So we're going to try that next. Instead of G1, G2, I want to show the name of the country. And then we'll say from sales S, join GOG on s.goid is equal to g.goid. So now that we have joined, I can select a g.go here. So that shows up the geography, and then group by this. We'll try this. If it doesn't work, then we'll have to come back and change this. Yep, it doesn't work. So we will need to have the same option as there. And then that'll give you. So whatever you're grouping by, you need to make sure that the summarization is also happening at that level. If you give a different column here, that's not going to work correctly. So now I'll get the geography here: New Zealand, Canada, USA, India, UK, and Australia, and then the total amounts, average, and boxes. This is more helpful than this report. This one tells me the data, but it doesn't tell me what these G1, G2, G3 are. So this is a bit confusing, whereas this is more helpful from a user perspective. So this is how the group by really works. You can group at a single level, or you can create multiple level grouping, just as you can put multiple items into the row label area of pivot table. You can do the same with this as well. So we're going to try one more grouping here. For the purpose of our second grouping, we are going to look at the people table and then get the data from team as well as product table and category. So we want to see what is the total amount that is coming in from a team and a category, and then understand that. So select from sales S, and then we will say, we'll probably need to build all the joins first, then come back and write the fields. So join people P on P dot SPID is equal to S dot SPID. Join products PR on PR.PID is equal to S.PID. So now that all the joins are done, we could come back and do this. So we'll say category P.team sum of boxes, sum of amount, group by, and then we will have to use these two options because that's what we are displaying on the top. So we'll try this. Sometimes when you write multiple joins and everything, occasionally you can make a mistake and you won't even see that. Unfortunately, there is no mistake, so it's all good. We will see what was the total boxes and the amounts for our combination of category and team. When you create something like this, it's a good idea to apply some sort of a sort order. So I'm gonna quickly show you how to apply the order by on this. So, and then we can add order by, and we'll do the same way as here. That makes more logical sense. And then when you run, you'll now get like bars, these 4 teams, bytes, these 4, and other, these 4 teams. So this is a more concise and better report than the earlier one. It tells you everything and then kind of gives you what you want. If you, for example, do not want to have the null team present there, the blank team, you can add a where clause as well. So for example, before you do the grouping, you can add the where clause where p.team not equal to space. If it is really null, then you would say is not null, but because in our data they're not nulls, I'll have to use this way. And then let's run this. So now we'll get even shorter report with that team gone, and this is coming up. If I want to impose a condition on this, one of these calculations, then you would have to use just as you're using where, you will have to use the having condition. I'm not going to cover having in this video, but that's another option that you have in SQL. We'll conclude our SQL learning with one last example wherein I want to show our total amounts by product and then show just the top 10 products. I don't want to see everything. So we'll try two steps. First, we'll see all the products, and then we will go and add just the top 10 condition. So this is where select from sales S, join products PR on PR.PID is equal to S.PID, and then PR.product sum of S.amount. So this alone should give you all the products and their amounts. And if I, for example, order by S.amount DESC, for example, we'll just say total amount, and then we'll see this if this works. Ooh, only one came up. It took me a while to figure out what was going on here, because I guess I'm completely out of coffee by now, but we forgot to add the group by condition. So that's why it was not giving the correct result. Group by PR.product. That should pretty much solve that problem. And now we'll see all these values in the descending order of the amount. So our highest selling product is after 9s, and then the lowest selling one is mint chip choco. But this is giving me a listing of all the products, and I just want to see the top 10 here. This is where I'm going to copy paste this query, and we can just say limit 10, and that will basically give you just the top 10 rows of the result. So limit is another operation on SQL that you can do. When you limit the output, it's gonna just limit, after running the query, it will limit the output to just the 10 rows. So that's really how you can get the top 10 values. Hey, I hope you enjoyed that video on SQL. If you really like it, please feel free to share this video with one of your friends or colleagues so they can also learn about SQL. And if you're thinking, this is all good, but how do I learn more about SQL? Then please feel free to check the resources section in the video description for my recommended books and courses and other websites and materials on SQL. I highly recommend that you bookmark these things and then check them out as your time permits so that you can improve your SQL knowledge. On the other hand, if you're wondering where would I use SQL, what sort of things that I can do now that I have got my data in SQL, extracted it out, then I suggest that you check out my video on how to get started with Power BI, which is a data visualization and analysis software that can use the data that you're producing from SQL to build visualizations and reports. Here is that video. I'll catch you there. Bye-bye.